Hello and welcome to all of you joining us here today for today's event on industrial power demand, where we'll be asking the question whether it is a strategic asset for Europe's electrification. My name is Dave Keating. I'm a journalist based here in Brussels. I'm going to be walking us through today's discussion, which is looking at different ways that industry can play a role in Europe's energy transition. Now, we all know that the Clean Industrial Deal, which came out early this year, while being technology neutral, places a great deal of importance on electrification. However, electrification in Europe has been stalling in recent years, stuck at 23% of total energy for the past decade. At a time when electricity demand should be increasing, it instead dropped by 7.5% between 2021 and 2023, before a small increase of 1% last year. This lag in demand is creating challenges in the power market. Those challenges include renewable energy curtailments, negative prices, and those all jeopardize the business case for new investments, which we desperately need in generation capacities. Now, while the technologies and challenges involved on the supply side are well understood and progress is underway, attention is increasingly turning to demand, a crucial but complex part of the equation. Beyond simply electrifying their processes, industrial consumers can actually play an important role in supporting the electricity system. For example, large and predictable baseload consumption can help optimize grid planning. That can reduce uncertainty regarding future electricity demand. Industrial consumers can also facilitate the integration of renewable energy by consuming power when overall demand is low, just like consumers can do. So today we're going to talk about the flexibility services offered by industrial consumers and what kind of role they play in keeping the electricity system in balance. We'll talk about what's already happening and the potential for industrial consumers to play an even bigger role in the future. So we're first going to hear a study on this topic called Industrial Power Consumption in Europe, Opportunities for the Power System. To present this study, I'd like to welcome here to the podium Fabienne Roch, who is Executive Vice President and Head of Energy Practice at Compass Lexicon. Fabienne?
Good afternoon, and thank you very much for the opportunity to present this study. As a modeler working for 2 decades in the power sector, I found it a very interesting exercise to change the perspective. For a good part of my career, I've been looking at the power system from the generation to the transmission, distribution, and then only to the end user. And for the first time with this study, I actually looked at it in the other way around. So starting from the end consumer and trying to understand what they can bring to this value chain and to the power system. So I believe this is the decisive new thing of this study, and I'm grateful to Metlen for sponsoring the study. Let me highlight the key points of the study. So the starting point, I think, is the predictability of power demand when it comes to industrial users. Why is predictability very important? Well, we've all heard that we know the destination. The destination is electrification of the economy, both for industry, but also for you and I in terms of transport, electric vehicles. It's also the case of buildings, right? But we also know that there is huge uncertainty regarding the speed at which we are going to electrify. Why is that an issue? Well, it's an issue because when you do your planning, as a power system operator, both a grid operator or simply the ones investing in the system, there is a value in understanding what will come in terms of demand when. And very concretely, that's a chart that I like that compares essentially the consumption over the past 5 years of the aluminium plants from Metlen in Greece compared with the overall load in Greece. And what you see is that obviously there are variations in the power consumption in the country that depend obviously on, for instance, the climate. Is it a hot year, a cold year? Depend also on the economy. You can see, of course, the effect of COVID in this period. But interestingly, if you are running an efficient industrial facility in your market, you are going to have a very predictable load. And that is very relevant in terms of how you operate that system and how you plan ahead. Now, the other thing that is remarkable, obviously, is that there are lots of good advantages with decentralized generation and decentralized consumption. I'm not going to be the one telling you that decentralization is a bad thing. It's actually a very good thing in many respects. But that does not mean that centralized offtake in a few key points is not helpful. And I think this is where you can get the best of both worlds by combining a centralized and decentralized system. And the fact that you know in advance, 20, 30 years in advance, where you are going to have an offtake from these industrial sites also has a value from a local perspective, because you can dimension the network in these areas knowing for a long time in advance where the offtake is going to come from. So that's the second type of value that we identified in our study. And the example here is essentially a map of Greece showing you the main industrial sites and their offtake. Now, the second thing that I think is worth highlighting, trying to move to the next one, just need to find a way to get it to move. Thank you. So essentially, the second thing I wanted to highlight is in the load shape. What you see here, again, on the chart, is different types of industrial processes, as well as different retail activities. So you've got hotels, you've got restaurants, you've got schools with education, and you've got construction. Naturally, as people get on with their lives, you see that we consume more at certain times of day, and this cyclicality has implications. We all know that there are peak times, and during these peak times, power is typically more expensive. And it's more expensive for a good reason. We need to start some of the power plants that are the most expensive ones, right? So the idea is that if we can flatten the profile and to some extent run more efficiently the power systems, then we will reduce cost. And I think this is where, again, having some baseload in the system, I'm saying some, it cannot be 100% baseload, but some baseload has a value from the point of view of the whole system, in the sense that you consume when some of the operators are not necessarily consuming, for instance, during the night. So again, it's one of the things that is often overlooked, the value not just of baseload generation, but the value of baseload offtake, looking at it from a different perspective. Moving on, very concretely, there is also the question of low carbon production. So we all know that renewables in particular, and I'm focusing here on renewables, if you look at solar or wind, there is some seasonality or variability even during the day for solar as to when they produce. So if there is an ability to maximize the matching between the production of renewables and the offtake of industrials, then that's going to enhance essentially the efficiency of low carbon procurement. And that's another thing that looking at it from the perspective of the end user, predictable baseload can bring, because then you can dimension some of your clean supplies and you can ensure a matchmaking exercise between the growth of your renewables on the one side and on the other hand, the off-taking from the industry in terms of clean power. I have another point. This is a third one that I think is well known, perhaps more than the first two. It's the flexibility point. Very concretely, a good number of industrial applications, not all of them, but a good number, have the ability to change their operations depending on essentially the price of power. They can decide to reduce a bit because there is some thermal storage in some cases, the load during some periods, or they can even decide in some processes to interrupt. What that means is essentially there is a large potential across Europe for industrial demand response. Some people call it interruptibility, but I think it's not just interruptibility. It's really how you shape your loads as a function of the value you can get from the system and provide to the system. Now, I'm showing you some potential estimates here in different countries, and you see there is already participation from industry in the energy markets on the demand response side, but there is a very significant potential that remains untapped today across different countries. I inserted a link here to another study we did focusing on the quantification of the value of flexibility. I don't have time today, but for those of you interested in it, the findings that I find relevant for this audience is that essentially industrials can actually make money out of this flexibility. And that can help to contribute to closing the competitiveness gap in the sense of helping some of these industrials by monetizing the revenues from flexibility, triggering the switch to electrification of their processes. It's usually quite small and there are some constraints, but it can be sometimes a tipping factor. Now, let me perhaps wrap up. I know my time is short, so I'll wrap up with some overarching comments and conclusions that we have in the study. We think that in order to harness industrial demand potential for the electricity system, there are roughly three main areas on which we can focus our efforts. The first one is obviously you cannot have an offtake if you don't have a supply in the first instance. So needless to say, even if you change perspective, you need to be too dense, right? So you need to scale up competitive low carbon energy. And here we have a number of recommendations regarding essentially the de-risking of the investment landscape for clean technologies. We have also, more specifically for industrials, the question of how they can procure this clean power in an efficient way, recognizing where they contribute to the system. And I have a concrete example. If an industrial user is contributing to reducing the network costs, well, maybe that legitimates a rebate on the network charges. If an industrial contributes to scaling up renewables, maybe that legitimates also reducing some of the renewables charges. So these are part of essentially the recommendations we have in the first bucket. Now, the second thing that obviously is needed is support beyond potentially the electricity tariff. What I mean by that, well, to electrify, you need to invest, and to invest, you need a business case. And to have a business case, you need the predictability. You need also support, often at the early stage, in order to finance these technologies, which may be more expensive today than their, I would say, fossil fuel counterparts. But with the hopes that by jumping crossing that bridge, essentially you get to a stage where you are again competitive through electrification. So this is where all of the discussion on state aid, CSAF, and some of the ongoing developments come in, and we have a number of recommendations there. And last but not least, and I'll conclude with that, flexibility is essential here. And what we mean by flexibility is having a regulatory and market framework that supports the monetization of flexibility. Now, we have in the directives at the moment in Europe quite a lot already on that, but what is clear is that this is not yet applied across Europe so fully by all countries. And much remains to be done also to provide incentives that recognize the value of flexible operation to the system, as I explained earlier. So I think I'll leave you with these words, and thank you very much for your attention.
Thanks so much, Fabien. So this gives us a good base to talk about the report and some of the larger issues now on the panel discussion. So I'd like to now welcome here up to the stage our panelists, who I will introduce now. We have Tom House, who is Advisor for Green Transition and Market Regulation at the European Commission's Energy Department. Come on up. We have Yannis Maniatis, who is a Greek S&D member of the European Parliament and also a member of the Parliament's Industry and Energy Committee. We have Martin Kuipers joining us online, who is an energy modeler at the International Energy Agency. We have Jean-Christophe Witschker, who is Marketing Director at the French utility EDF. And we have Nick Keramidas, General Manager at the EU Affairs and Regulatory Division for the energy and metallurgy company Metlin. Thank you all so much for joining us today. As you may notice, we've unfortunately ended up with a panel today that is an all-male panel. We usually try our best not to have that, but sometimes it ends up, in the end, all of a sudden you realize, sometimes last-minute replacements end up making this happen. I will say I moderate on a lot of different topics, and this happens a lot in the energy sector, so maybe something larger to think about in the energy sector, why this is so frequently the case. But anyway, we apologize for that. So let's talk about what we just heard about in the report, particularly how the industrial players can play this role in contributing to the energy grid and contributing to these flexibility needs. Tom Hauser, I'd like to get your reaction first from the Commission's perspective to what we just heard.
Sure. Well, firstly, it's a great study. It's always good to get a deep dive and good data about what could be the potential for electrification. We know electrification is good. We've got the KPI from the Clean Industrial Deal. We know we want to grow electrification. It provides it's one of the cheapest ways to decarbonize. It provides security benefits. So in general, it's a good thing. With industry, we know industry is consuming about 25% of our energy, but only a third of that is electricity. And we think there's major potential within industry to electrify. All sorts of particularly low and medium temperature heating processes could be easily electrified with today's technologies. On that basis, given that that's a good thing, we want to zoom in on how do we make that happen. Partly we're addressing that through the Affordable Energy Action Plan, where we're looking at grid tariffs, at connection regimes, the way the market's functioning, the way tax regimes work, and making sure that we're reviewing all of these to make all of these different levers incentives for greater introduction of demand and greater load. And flexibility is part of that as well. The increase in load is great, but if that load is also flexible, it helps operate the system more optimally. So that's another reason to encourage the flexibility in the market. So overall, it's a great study. It provides some good data, and it's carrying on the Commission's message of electrification being a good thing, and let's implement.
Thanks. So in line with the Commission's thinking, for sure. I did forget to mention, you guys are also going to be able to participate in this discussion via Slido. So you can put in your questions via Slido. You see the QR code just come up on the screen. Type in your questions at any time. I'll get them on my tablet here. I'll put them to the panelists at the end. You can also ask questions about the report. Fabienne will be here also to answer your questions about the report. Now, MEP Maniatis, what is your reaction to what we've just heard in the report?
Well, first of all, I have to say that this study was an excellent introduction to our issue. I would be happy as a parliamentarian to see many such studies in order to tackle the problem that the energy-intensive industries in Europe are facing. If I can start with some basics, we have already discussed that the industry sector is maybe the biggest consumer in energy, more than 25%. High energy cost is at the core of a challenge we are facing now also at the parliamentarian framework to see how through the so-called omnibus we can simplify the whole process, the whole framework. My third point is that electrification of the economy is one of the main policy goals. We have discussed about 32% as a non-obligatory target, but this is our target. And finally, electrification has the potential to be a key driver of a more resilient, competitive, and climate-neutral production framework. Now, talking about electrification as an opportunity, as a challenge and an opportunity, one could say that, first of all, we need more investments maybe in CapEx, but also in OpEx. Second problem is where we have failed as European Union is to have lower electricity prices among the member states and among the different regions in the Union. Of course, always when we compare the European prices with the prices in the United States or other, it's a tragedy. In Europe, we have 3, 4, 5, 6 times higher electricity and gas prices. The third point is that from the industrial point of view, there must be improvements in order to improve their own flexibility for a new era in energy. All these without deteriorating the working conditions for workers, for the broader environment, for the whole society, etc. And in other words, not follow the fluctuations in price to be followed by fluctuations in working conditions. And my last point is that we need to see how the current or the future electricity framework can evaluate the costs and risks when one energy-intensive industry will follow all these changes we're discussing upon. For example, what will be the loss of production? What will be the maintenance increase, the cost of maintenance increase, or maybe even in damages, where there could be some other consequences. And of course, in any case, to organize, as we have already seen, to organize the day-ahead markets, the flexibility markets, and the capacity to have a capacity mechanism. In other words, to know how we can detrap the energy-intensive industry in Europe from all this framework we have organized towards green transition. We all agree on this, but always we must see what our competitors are doing. And having lost the cheap Russian gas anymore, we need to see how we can support this productive base of European economies in order to support them from a financial point of view, from a legislative point of view, and at the end of the day, to help our societies to survive and our industries and entrepreneurship to survive in these difficult conditions.
Jean-Christophe, what is your reaction to the study from the perspective of a big energy company?
So we at EDF, we share the overall conclusions of the analysis, and sharing Fabien's view, it's quite unusual to look at things upstream, going from the consumer to the electricity system. But I think that's really a trend that we can observe within the system, with consumers being also generators or non-consuming, if you like, which is a little bit the same as generating in a way. So now that low carbon sources are more abundant within the generation in Europe, electrification is key for decarbonization. I think we all agree on that. And that's especially the case for industrial sectors. And we've been working with our customers, with our industrial customers, for over 25 years on this very question: how to electrify their demands. But I have to say that in most cases, the economics were not compelling enough to make them, jump the fence and electrify. But now this is changing. This is changing because the emission prices are higher, but also because there is more abundant low-carbon generation from renewable and from nuclear. But then our industrial customers are telling us, okay, it's all fine electrifying, but what happens if there is a massive uptake? Is it going to drive prices up? And then what do I do? And this is exactly where flexibility comes in. Because in the current market, the system is not very, is very well balanced. There is plenty of space to accommodate electrification. So, because also there is a lot of renewable generation, there is a lot of variance within the same day on spot prices. In France, typically between 50 and 80 euros per megawatt hour. So there are massive opportunities to be taken, to be obtained by industrial customers who are able to put their additional consumption from electrification on the cheaper time periods. And also that avoids some curtailment of renewable generation. And so there are some sectors which are very well suited to that, those using a heat storage, for instance, boilers that can be hybridated between electricity and gas. And another example is manufacturing, where you have electricity-intensive batches that can be planned for the cheapest times during the day. But then what happens if prices are up due to electrification? Then, because if you have flexible demand, then that helps keep the system balanced. Because you have capacity and ancillary systems that are accessible to industrial customers, and they get paid for their capacity to remove some consumption at times of tension. And what I have seen during energy crisis is a benefit of typically 500 euros per megawatt hour for each non-consumed megawatt hour. So again, there is some value to be gotten from the system, and that's very well suited for ovens, for instance, high temperature ovens, because you have some thermal inertia that enables you to switch the power off for a short period of time. So if I want to summarize, there is some value to be extracted by industrial customers from the flexibility of demand, but we need to bear in mind that in the first place, that's the system that's responsible for keeping the lights on, keeping the system balanced 24/7. And it's one thing to encourage, to incentivize flexibility, but not every industrial process can achieve that. And so encouraging is one thing, mandating is something totally different that we are not supporting. And flexible demand can only come as an addition to flexible generation that's both low carbon but also dispatchable. Yes, and there is one final thought I had. I won't take too much time, but industry's orientation is long term. So, because if you want to secure investments as an industrial, you need to have a stable and visible regulatory framework. And that's really paramount if we want to achieve electrification.
Great, thanks. I think those are all very good points. Nick, let's turn to you next. From Metlin's perspective, what jumps out at you about the study?
Thanks a lot for having me, and much has been said already by the fellow panelists. So the findings of this report basically help recalibrate a little bit the discussion in Brussels around the interplay between the power sector and electro-intensive industries, I think. So there were two main triggers that kind of led us to this report and seek external expertise from Fabien and his team, who did a marvelous job, by the way, shaping the report themselves. One was this rapidly growing problem, both in Greece and other European countries as well, of renewables curtailments. And as well as the decline in renewables PPAs, you know, the plain vanilla PPAs, power pay as produced and so on and so forth. And also the increasing zero and negative prices in the wholesale market, which some people celebrate, but in fact is a symptom that should be taken very seriously. At the same time, we've been seeing a discussion around Brussels, which was kind of superficial, about industrial demand flexibility. And we thought it was, you know, there was merit in deep diving into that. So I think the report shed light on principles and realities of the power sector. And, you know, again, its interplay with consumers, which we have known more or less for decades. But these realities basically help, you know, shape the development of the grids, the development of power generation in a cost-effective manner and efficiently as well, and to a large extent reliably. But somewhere along the way, I think we kind of unintentionally decided to overlook them. Truth is, driven by an absolute focus on emission reductions over the past few years and slightly disregarding reliability and affordability, sometimes not slightly, we ended up sort of forgetting consumers. And I think Jean-Christophe already mentioned it. In 2025, in the Western world, developed world, the power system has to be geared to serve demand in an affordable and reliable manner with the lowest emissions possible, not the other way around. So I guess the question that the study ended up responding, and I think it's very, very useful, was setting aside all the discussion that we find in the Draghi report and about, resilience, strategic autonomy, and economic growth, and defense, and jobs, and all the contribution of electro-intensives in this framework that we're trying to build. How are they, power-intensive industrial consumers, good or bad for the power system? And I think the presentation that Fabien gave us was a very, very clear response to that, and we want to thank him for that.
Great, thanks a lot. Now let's go to Martin, who is joining us remotely from the IEA. Martin, what jumped out to you about the study?
Hi, good afternoon. Also from my side, and first of all, I would also like to thank very much for the report. Very interesting findings about a very relevant topic at the moment, industrial electrification. Basically, industrial electrification has also been a deep dive of our latest World Energy Outlook published last week, especially in the regional section about the EU. We have shed light on the topic. Also because we see that, especially in industries with low and medium heat temperature requirements, we see progress in the EU stalling, and the share of electrification is basically on a similar level as, for example, in the United States, while other countries such as China, Japan, or Korea, who also import, for example, natural gas, have a much higher share of electrification. So this just underlines the need to increase electrification and the potential to increase it. We also see what was mentioned earlier in the panel, that it's not competitive at the moment. So there are several options to increase competitiveness. Of course, on the one side, technological progress, and on the other side, also having flexible pricing, using PPAs for a certain amount of the time can be helpful. But this is not all of it. There are also technological elements of flexibility, and some of these also have already been mentioned. We see the potential of hybrid systems, especially electricity boilers working alongside gas boilers as one possible solutions to increase electrifications gradually, especially in hours where prices are low or the load is low. We see a big potential for thermals, for daily cycling, or to offer faster response also for ancillary services, and also a potential on the sort of electricity side of the system through the management of grid connections to make those more flexible, potentially even depending on time use and reducing and giving the TSO some option also to intervene when already allocating some grid capacity to customers. One last topic I would like to flag, which is a bit more overarching and which we are working more and more on in the context of the energy sector, which is artificial intelligence, which we think has some potential to improve the operations of flexibility, especially by improving the forecasting capabilities, prices, renewable availability, but also the availability of flexibility. So artificial intelligence can help integrating all of these flexibility measures.
Great, thanks, Martin. So I want to talk about, we've been talking about industry in general, and I want to focus in on what specific sectors might be the best primed for offering these type of flexibility. So Tom, when the Commission is looking at different sectors and how their flexibility contributions could work. You've got aluminium, you've got steel, you've got cement, many other energy-intensive sectors. Which do you think are the sectors that are best suited for this type of flexibility?
Well, firstly, I think it's a great question because we've got to be nuanced in the answer. I can, for instance, identify cement, but in fact, within cement, there's the grinding process within cement. So it's a sub-element of the industry, which can be easily electrified, but not necessarily other parts of it. So we need to do a deep dive in each sector when we come up to that. But in general terms, there's the food sector, food and beverages, pulp and paper, already doing quite a lot of electrification. Certain metals, non-ferrous metals are not everyone's obvious first choice, but again, there are some processes within that where those can also be electrified. So there's a range out there. I mean, one way we'll see what's first off the blocks is with the 1 billion innovation fund budget that we have at the moment, where we're putting up 1 billion to call for projects to electrify or otherwise decarbonize low temperature industrial processes. So that will give us a first flavor of who's ready to jump for this money and who should be first off the block.
Jean-Christophe, when you're working with various different heavy emitting sectors, who do you think are the best placed to help out here?
Well, we have a view that there are 4 sectors which concentrate about 70% of the potential. And so some of them you have mentioned already, metal industry, chemistry, mechanical industry, paper. Many of the sectors using heat or cold are well suited, to interruption, because then there is some inertia in the process, and so you can interrupt. So you can either interrupt in periods of tension, or you can select the times when you are going to activate the process when it's cheapest actually. And so you can see that so in processes using heat, you have that also in electrolysis, because in the electrolysis you can decide to stop and then resume, something you can use in aluminium in a chemical industry. And you have, but you mentioned that, Tom, already, the grinding process for the cement industry.
Martin, same question for you. From the IEA's perspective, what sectors do you think are best placed to help out with this flexibility?
Yeah, I think in terms of sectors, I agree with the ones mentioned. For the reasons mentioned, we are also strongly looking into those sectors such as food with lower temperature requirements. One point I would like to add to the points mentioned is that the industries also have a different concentration. Energy-intensive industries are rather larger plants, big clients, big companies. So there it might be easier to also harness the flexibility potential. Whereas if you go more on the manufacturing side, for example, in the food industry, you enter into a larger number of plants, more players in the market, so it requires more coordination. So apart from just the industries, this is also an implication of the sector to choose for the flexibility potential.
I think we have a commercial playing somewhere here. I heard something about Black Friday. Nick, let's go to your specific experience on the ground of Metlin. What would you say are some of the practical realities that Metlin is facing on the ground to adjust to and support the electricity system? And how have industrial consumers been able to facilitate the integration of renewable energy, for instance?
Okay, thanks for the question. And I'm going to try and also respond to some of the comments that were already made and maybe clarify. I don't want to come off too strong here, but the job of an aluminum smelter is not to, or a chemicals producer, a cement producer, or whatever, steel, EAF, is not to facilitate the integration of renewable into the system. Like the power system has a role to play, and our Prime Minister submitted an article in the Financial Times a few weeks ago, which kind of explained that for industry and households, for governments as well across Europe, we got two pillars that we need to be very mindful of in this transition, which is, reliability and affordability, which for us translates in competitive power costs. And I think MEP Magnatis will kind of echo that. And basically he's been saying that for maybe a decade or so already. And you see that manifesting in different parts of Europe. So following the blackout, for instance, in Spain, you've seen the TSO keeping more gas on the grid, which kind of leads to more curtailments of renewables, but which, in effect, increases slightly emissions, but reliability matters a lot. And you see also member states like Germany, like Italy, and so on and so forth, and trying to figure out ways to support their industry, even though they're asking for baseload power, and trying to find a way to subsidize their power costs into something that will more or less compete with their peers abroad. So affordability matters as well. Now, when it comes to us, in particular Metlin, smelters have a very specific consumption profile and very, very specific technical characteristics, right? We need 24/7 electricity, but as Jean-Christophe said, we can offer load shedding services like interruptibility, which has been the case in the past. Due to our size and our really fast response, the aluminum smelter in Greece, as the aluminum smelter in Germany, have averted blackouts, actually. So this is something that we can build on, but it does put strain on our facilities, right? And it does compromise to a large extent also our output, our industrial output. So we expect to be remunerated for that. And in the recent past, we've had some interruptibility schemes running in France, I know, in other places as well, Germany and so on and so forth. Now, I know that the European Commission is not very fond of interruptibility mechanisms per se, at least not DG Competition, no, no hint to Tom here, our friend. But in the CSAF, for instance, the Clean Industrial State Aid Framework, we saw that demand response by industrial operators is dealt with at equal footing with storage when it comes to non-fossil flexibility schemes, for instance. Battery operators, and we're one of them, by the way, we are an energy and metals business, so we are on both sides of the equation. Battery operators, that's their job, right? That's how they make money. By doing that, the arbitrage, the reliability services, and so on and so forth. We make aluminium, that's our job. And if along the way we can also help the system be more flexible, then we need to be remunerated for that, and it cannot be compared against the bid of a battery operator. Unfortunately, we can't meet that because our main job, again, is to deliver the goods to our downstream operators. By the way, when you mentioned barriers, for instance, we have another issue which has prevented us from tapping into the renewables potential and the flexibility potential to some extent, which can also be found in this recent framework, the CSAF, where they ask of us to build on-site renewable generation to decarbonize our processes. Now, the aluminum smelter consumes, 3 terawatt hours a year. I don't know how many understand the meaning of terawatt hours. It's the equivalent of roughly 1 million households. If we build a solar rooftop PV, we can probably cover a bit less than a day's consumption over the course of a year. So on-site doesn't work for us. And by the way, the best match would probably be wind or something like that, which has a way better profile. But we're still trying to exhaust the potential to become as flexible as possible and deliver, though we have to maintain utilization rate above 80 or 90% to be competitive at global scale, to deliver as much as we can to the system. What I want to finish with is the market signals. A lot of people suggest that market signals will deliver flexibility. Last August, we had in Greece 900 euros per megawatt hour for consecutive weeks during consecutive hours of a day. That should suffice as a market signal for a smelter operator because it translates in roughly $13,000 per ton cost of electricity at that moment. So our selling price is roughly 2,500. So if we could cut our consumption, we don't need an extra signal. Trust me, we would have cut. We can do as much, and we can only deliver to that extent. We can't be asked to become a load-following operator, to follow, let's say, the solar curve or the wind curve or something like that. That's for the power system to ensure.
MEP Maniatis, I want to get your responses to some of that, particularly in terms of policy options. So we heard this idea that there should be some form of remuneration for the activity that's being done here. How is that possible to do from a policy perspective? And what other types of incentives could be put in place in order to make industrial electrification investments viable and timely?
If you allow me, following this, the comments from the colleagues and friends, I want to make one or two political comments. First of all, here in Europe, till now, we did not love industry. We did not want to hear that there is industry or that we need industry. We were happy enough to import from, for example, from China, our 80% of photovoltaic panels. We did not care on this. On the other side, we did not care to import our foods from other areas of the world. Today, we have started, at last, discussion about strategic autonomy. Strategic autonomy means improving, empowering, developing, giving more attention, giving more incentives to your production base. If you want to have your production base, you need to have cheap energy. There is nothing else. And we have discussed, we have produced millions and millions and millions of pages on regulations, on the Commission of Competition among the member states, as if there is no other world outside. And now we have understood that, okay, we are not competitive one member state with the other, but we as European production base, as European Union, we have competitors from China with concrete incentives, and we have competitors from India and United States. So I think since Mario Draghi and Enrico Letta have described this condition, they have proposed. It's not just a description. I would be very happy if the European Commission, the European Council could follow these instructions, because talking from the point of view of the European Parliament, I can tell you that at least the four pro-European parties, the biggest one, the European Public EPP, we as Social Democrats, Greens, and Renew have fully understood what are our problems. And Nikos has, for example, described the problem in Metlen, in Greece, in aluminium industry. We did not care if half of the plants in Europe producing aluminium were closed. And we do not care if we import aluminium from outside with much, much worse environmental or human conditions. Why I'm telling this? Now, I hope that we have understood that we live in another era, in another planet, different than the planet 5 years ago. We are alone. We have a non-competitive industrial base due to the energy costs. We cannot anymore afford natural gas, LNG, from United States, from Louisiana, to start with a unit price of $3 per unit and arrive in Europe in $12. What's happening inside? Someone has profits not acceptable by a normal economy. To answer to your question, not to avoid your question, what we should do. We know, everyone, every government, everyone knows what we should do. First of all, Administrative burdens, better administration, smarter and faster permitting processes. A financial sector strong enough in order to support it, to provide significant funds to the industry. Lower electricity prices. We know, Commissioner, who's a friend of mine, Dan Jorgensen, knows the problem. He's trying to solve the problem, but in order to solve the problem, it is also the 27 member states that must agree on it. And there are problems on such fair communication and debate among the different governments. Maybe, if it's necessary, we need to have tax incentives, and at the end, not forget the social justice. We in the parliament have 4 far-right political parties. Why did they exist now in the European political scene? Because the societies are suffering by poverty, and especially by energy poverty. So it is not only the industry, that the European industry, that is suffering due to the high energy prices. It is also the societies. And if we want to avoid surprises in the future, we need to stay by the industry, by the societies, and to understand that we need to think in a new revolutionary way. And let's take concrete examples from our competitors. We are, I repeat it, and I finish with it, we are alone. We have to protect our societies. We have to protect our rule of law, our citizens, and our achievement as European Union, because we are proud for the European historical experiment, and we must keep it safe and competitive to other models.
Well said. Jean-Christophe, same question to you in terms of the incentives that might be possible to make industrial electrification investments more attractive, more viable, more timely. What are some of your ideas for what incentives could be put in place?
Well, I think first and foremost, so there needs to be a long-term view on this, with clear political frameworks and that provide visibility for the industry, so that they are able to invest, and secure the return on investment. And so that's really key. And even the best and the most incentivizing market signals will not provide a great effect if they're only short-lived. When there are energy crises, then you have the capacity markets that jump, which is fine, for additional for capacity, for interruptibility to intervene. And we could see that, and I could see from Fabien that the 5 gigawatt already tapped potential in France, which is something. It is something that we could verify at the end of 2022, when there was some constraints on the French energy system. But the capacity market has gone back to zero as a value. So if you're in an industrial, how happy would you be, with your investment from 2022 or 2023? 3 years later. So that's one thing. Looking more at the processes and how we need to support an electrification of the industrial processes, I really believe that the main obstacle to be addressed in the investment gap, and there needs to be some financial support for that, depending on the level of maturity and on the economics of the process to be electrified. So looking at heat below 150 centigrades, for instance, existing technologies are mature enough. I'm thinking heat pumps, industrial heat pumps, electric boilers. And so that requires only limited support maybe some capex subsidies just to make projects arise faster. Whereas if you above 150 centigrades, although the technologies are already mature, there is not enough gap between gas and electricity. The EU ETS price may be now at a relatively higher level than before, but it's still very erratic, and we don't know what it's going to become, in 2 years' time. So then there is a taxation gap as well. So there are additional measures that will be needed, not only to support capex, but also to support opex at the beginning of the life of a project. And that's really the condition to which you can see technologies becoming more available and so more widespread.
Tom, I wanted to ask you about really how we get to some of the targets that the EU has set. So the EU has a reference target of 32% electrification by 2030. What enabling conditions are needed to get there in terms of providing this type of flexibility?
Sure. I mean, firstly, we call it a KPI, a key performance indicator, different from a target, but it's giving a direction of travel and an expectation, which is what's useful. I think we're in the middle of doing all sorts of things, whether it's looking at, as I mentioned before, each element of the sector, whether we're looking at grid tariffs, the way the market's working, the way grid connections are working, the way flexibility is introduced through the suppliers and the engagement with off-takers. There's lots of conversations ongoing where these different measures are being picked up and providing the signals that we need to bring on more demand and to bring on more flexibility. We're coming out shortly with the grids package, which will look at further elements of the way the grid is developed, the way connections are managed, and the way tariffs are charged. Again, helping off-take increase their capacity to electrify. And in addition to that, next year we're coming forward with both the Electrification Action Plan and the Heating and Cooling Strategy, which will again be doing deep dives to see which sectors and subsectors need help, what the right financial instruments are that can help do this. We're engaging more with the EIB, the European Investment Bank, to do things, for instance, like have guarantees for PPAs. So I think there's a lot out there that we're doing. We're picking it up with tripartite agreements, where we're trying to bring all the different players together, the member states, the off-takers, and the suppliers, to get commitments about what each party can bring to accelerate all of this and to actually make it happen.
Martin, I want to get your perspective on this as well. What would you say are some of the key enabling conditions that are needed to make this happen?
I think the key enabling condition is competitiveness. So making electrification competitive advantage or competitive option for an industrial player to switch. For this, we need clear electricity price signals. There are some policies in place which show already some progress. The EU auction was mentioned. Also, in some member states, there are carbon contracts for differences targeting the industry sector. For example, in Germany, it had a big success for electrification projects. So one, giving a clear signal on electricity prices for industrial customers so that they comfortably change to electrification. Then I think it's also promoting those examples because it always depends on the industry, but promoting good examples of integration of heat pumps, of hybrid systems, of thermal storage, some new technologies coming in, and sharing the knowledge across different industries or within an industry to further integrate those solutions on a broader basis. And then it's also, of course, the enabling conditions, having the grid in place, accelerating grid connections, because with the target or with the KPI of the EU to increase electrification will increase in several sectors. There are data centers coming online, so there is a queue of new customers coming to the grid. So the grid will play a central role. in the past, in our tracking, we have seen that there has been much more investments on the generation side than on the grid side. So the grid will require significant investment, but also the flexibility we have talked about to effectively integrate the new electricity demand.
Thanks. So MEP Maniatis, I know you have to leave us to go back to the Parliament. Any closing thoughts before you go?
Yes, if I may say two things. The first one, and I am the shadow rapporteur on the new Connecting Europe Facility mechanism. And what I can say is that at the energy sector, the previous MFF had about 5.6 billion euros, 6 billion euros. Now we will have 30 billion euros, which means 30, multiplied by 6, which means that one of our problems we're discussing here, which is the missing links among the national grids, the national electric grids, we will have the opportunity through the new Connecting Europe facility to connect the national grids in order to have easier transportation of energy goods of any kind. And my second, not so optimistic as the first one, my second comment is that we have now a danger because we are discussing now the new MFF, the new multi-annual financial framework. There is a direction, an idea from the President of the Commission and the Commission to divide, to separate each program in only national programs, which means instead of having one common European agricultural policy, instead of having one common European energy policy, instead of having such policies common European, maybe we jeopardize to have fragmented national policies, which will be a catastrophe for the whole European vision. I hope, because we will discuss this new MFF for at least 1 year, I hope that at the end we will go towards a more unified European Union in many sectors, and especially here we are talking about energy. I'm also, as Vice President of Socialists and Democrats, responsible for the defense issue. Defense is 800 billion euros. How we will invest or spend this money? What we're trying to do is to do it in concrete European regulations and rules, not each one separate. Because on the other side, we have concrete, unified international entities that compete our own societies and our own industries. Thank you very much. Excuse me, I have to leave. Thanks for inviting me.
Thank you so much for being here with us. So we've had lots of questions come in via Slido. I'm going to go to those in a moment. But first, Nick, just one last question to you before. It's come up a couple times, competitiveness, and particularly global competitiveness, that as we're doing all of this, or the lack thereof, now as we're doing all of this with flexibility, how can industry contribute to grid flexibility here in Europe while also remaining competitive globally, particularly in sectors like yours, which are global sectors?
Yeah, indeed. So our sector is it's a globally traded commodity. So basically, just like I said before in the previous question, I'm afraid I'm going to have to invert this and state that we first have to be competitive at the global scale, and while being competitive, be in a position to offer as much flexibility as we can to the system. Competitive is, a relative term, right? So competitive means comparing against your peers. And I think MEP Mañates mentioned that the relevant market right now is the global market. So we're competing against the UAE, China, Indonesia, Vietnam, Canada, Russia, the United States of America, and so on and so forth. A lot of these players, by the way, and I think MEP Mañates also mentioned that, have like a triple carbon footprint than we do. So even from a climate perspective, it makes all the sense in the world to keep producing this stuff in Europe. Now, when it comes to how we can provide flexibility, I'm going to go back to a comment that Martin made about electrification. He said that there are ways to electrify certain processes, particularly low heat processes and so on and so forth. I think when it comes to incentivizing electrification, the best way to do it is make a success story out of the electro-intensive sector that is currently operating in Europe. Right now, we're doing the exact opposite. We're seeing the most electro-intensive part of our industry fading away. It's 1 million tons of primary aluminum production that's gone over the past 3 years. That's half of our output that's gone. And it's been replaced globally by a smelter in Indonesia hooked to a coal plant. Make no mistake about that. And when an industrial operator that can switch to electricity sees that example, his first option would not be, let's do that. Okay? So it makes all the sense in the world to try and fix the issues that the bellwethers or the front runners are facing. And these are non-ferrous metals, these are EAF steel, these are some other industries that have already electrified. If we can make it work for them, then we can definitely make it work for the rest of them as well.
Well, let's go to some of the questions that we've had come in from the audience. Martin, I'm going to put this first one to you. The question is from Kieran Foster. Is the need for industrial electrification being threatened by a recent focus on technological neutrality? Does the EU-US trade agreement that was agreed in July, which commits the EU to large purchases of gas, also undermine the push for electrification? That agreement in the July trade deal with the US, if actually implemented, would mean the United States is Europe's only gas supplier. Martin, I guess there's two questions in there. Does this huge commitment to buy gas undermine a push for electrification? And does the commitment to technological neutrality from the Commission also undermine it?
Yeah, very good question. I think the answer is that it's still a demand-driven market. So, of course, there's this framework agreement, but in the end, the individual plants in the European Union and the companies running those plants will decide whether they will run on gas or electricity or any other fuel. About the technological neutrality, I think, of course, there are other technologies that can provide heat for industrial processes. But for electricity, we, on the one side, especially when looking at the EU targets to also reduce emissions, on the one side, we have increasing supply of renewable generation. And as was already mentioned by Jean-Christophe, we have lots of technologies that are already competitive. So from the IEA perspective and how we build our scenarios, we always go technology in a technology neutral way to our analysis. But there are other constraints such as the availability of biomass, the availability of geothermal, solar thermal energy, which make it more complex for other fuels. So electricity is widely available, deployable, and is a very attractive option if at a competitive price. And as mentioned, that's the key ingredient to increase the share of electrification in the EU industry.
Tom, I want to also put this question to you. I know you're limited in how much you can say about it, but if we are, the Commission can't instruct the private market what to do, no matter what commitments were made to the United States. And yet, if this LNG infrastructure is built, we do risk a lock-in in terms of having a whole lot of infrastructure that then requires gas to be imported in order to justify the investment in the infrastructure. Is there a risk that we are undermining the push for electrification by being forced to buy all this gas from the United States?
For the reasons that Martin said, I think not. We think there's a flexibility within the framework agreement and that it will be market-driven and market-led. Whether there's new infrastructure that needs to be built to absorb some of that, it's all about meeting our short-term needs for flexibility, which at the moment can come from gas-powered power plants providing that flexibility. So in a sense, LNG and gas is a transition technology and fuel on our pathway to ongoing decarbonisation and electrification through other means, through other forms of flexibility. So no, we see it as a short-term need, given the absence of Russian fuels, but not inconsistent with the long-term objectives.
What do you do with the long-term infrastructure if it's only a short-term need?
There's a question of how much of that gets paid off over what particular time period you're talking of. So what are the payback periods? What's the accounting regime that makes that a good medium or long-term investment? So obviously we'll try to be designing those different regimes in financial incentives to ensure that there isn't a long-term lock-in, and ensure that wherever it's possible there are hybrid solutions, whether that's in the power plants or in other forms of infrastructure. We're already looking at the way existing gas infrastructure can become hydrogen infrastructure or otherwise gets repurposed or decommissioned. So we're already grappling with the regimes we need to be able to ensure that outdated fossil-only infrastructure isn't locked in and undermines policy. It's actually converted to become part of the decarbonisation story.
Okay, next question is for Nick. That question is from Loïc Delorme from CHC. One way industry could support the grid would be by making their waste heat available for lower heat uses and district heating. But it's still pretty rare. What are the barriers for making waste heat available?
Well, some of the industrial facilities, and I think Fabienne's report alluded to this, are concentrated in places where you don't have that high requirement, like a concentration of houses and so on and so forth, for it to be justified, or economically justified, or technically even justified, to go for a solution of district heating. Actually, we have assessed that for our own facilities because we operate alongside the aluminum smelter. We also, given that we're vertically integrated, we have an alumina refinery. So we have a cogeneration facility running on gas, delivering the heat to the alumina refinery, turning bauxite into alumina. And we have assessed the possibility of going for district heating and cooling, ideally. So cogeneration is the best way to do that, by all means, both for industrial purposes and for district heating. So we have tested whether or not we could even seek to cover the needs as far as heat's concerned for the people living close by. So it's already 1,200 homes, but unfortunately the economics are not there. So it's a very tricky exercise. It's a very, very technically heavy exercise. And the volume of heat actually needed, I mean, in theory it sounds good, but the volume of heat actually needed, unless you switch to a heat pump or something like that, would not justify changing the operational mode of our CHP facility. Can I maybe just comment a little bit on the previous question that was made? Because I think Tom responded very well. Kudos to the way he framed it. But I also think that we need to understand that electrification doesn't clash with gas, okay? We seem to be thinking that, in Europe that electrification only comes from, grids, renewables and storage and so on and so forth. Electrification comes a lot from dispatchable generation and flexibility services and ancillary services that are currently offered largely by gas plants. In some cases, there's hydro availability, which is also catering for that, and slowly but steadily, storage is advancing. But in our effort to become more resilient and secure, I think it's also fundamental to understand that we used to be totally dependent on Russian gas. We're now almost totally dependent on China for renewables equipment and storage. China is actually gaining ground on wind a lot, so their quality has improved. Their prices are insanely lower than those of domestic operators. And so switching one dependence for another is not ideal. So we have to recalibrate that a little bit, make sure we factor in reliability of the system and strategic autonomy and safety of the system, because we've seen some examples lately of kill switches and stuff like that we want to avoid in the future. We don't want to have those. So buying gas from the United States, I guess, I'm not talking about the volumes of the deal and stuff, but some diversification was definitely needed there. So.
And you're right that electricity does partly come from gas. It's not that they're two entirely separate things. So the next question, I think is for Fabienne, who do you have a microphone nearby? There was one on the floor, and I think it might be on the chair now, if you see one over there. That's my fault, I put it down there. So this question is from Frédéric Simon from Carbon Pulse. Has an assessment been made of the decarbonization potential of electrification in industry? What are the low-hanging fruits? And you could come and stand maybe so people can see you. You can stand up where those orange tapes are there.
Well, there have been a number of studies looking at the decarbonization potential of various industrial sectors. In fact, we've been working with my colleague Florian Boursier, who is in the room, on trying to do an overview of this. There are multiple studies that have been done. Now, the challenge, as I think was very well summarized by the panel participants, is twofold. I think the first challenge is to understand, the technical constraints and what triggers the switching from an economic point of view. The second challenge is also that every single installation, to some extent, is unique in the sense that when we look at these average numbers, very often they don't necessarily represent the reality on the ground of all of these installations. At least that's my experience talking under the control of the industrials, the real ones, on the panel. But I don't know if you want to comment on this.
Absolutely true. And clearly we've been looking into the potential of going for electrification of the heat-intensive processes. One of them is the one I mentioned earlier, alumina refining. Unfortunately, the specificities of the bauxite that we're using and the super high temperatures that we need, along with the baseload heat supply, we need a massive amount of heat. I'm not going to trouble the audience with figures here. But that means that essentially we would need a huge gas plant to run baseload to deliver that electricity to the boiler in order to deliver the heat. Right now, instead of doing that, we're doing it in the best possible way, which is a cogeneration facility, which is high efficiency, and it delivers both power and heat in the best available way. And I think to this extent, shooting for the stars, sometimes, as Fabienne said, we can do it when we take a bird's eye approach, like what can be done in industry. When we focus more closely and we realize that no, not everything is as easy as it seems.
Yeah.
On this, it's very true that you have to have a very bespoke analysis of the electrification potential of a facility, and looking at things that wouldn't come to your mind in the first place. And this has been mentioned twice, I believe. Availability of grid connection is one huge issue, and something which in France, where although the grid is pretty well interconnected, I can think of two examples that are very similar in their principle on the processes that are involved, and one is feasible in the short run and the other one is not, because of availability of connection to the grid if you electrify. And in one case where it's less favorable, you have a 4-year wait, to to get your connection, and then it's just all this time wasted.
Martin, next question is for you. This question is from Megan Richards. European industry is relatively energy efficient compared to that in the USA, for example. Is there potential for even further efficiency in industrial processes via AI, new innovative methods, etc.? Digitalization and modernization of electricity grids will be essential to take advantage of demand-side flexibility, and will those decentralized systems be able to meet those standards?
Yeah, very good question. Basically, we have done a report on the interconnection between energy and AI in April this year. Where we have asked ourselves exactly that question. We have basically looked at case studies in different industrial sectors. So we have gone really sector by sector because challenges are different. The progress on energy efficiency is different. Solutions are very different. And we have found that usually there is an efficiency potential between 3 and 8%, depending on the sector. The potential is much higher in industries with lower temperatures, where energy makes less important part of the production costs usually. Industries such as aluminium, steel, where energy makes an important part of the production costs, are usually already quite efficient in their operation. But still, we see around 3% potential through learning from historical patterns, really using the data from historical patterns and using the sort of bigger potential of analyzing this data through new AI algorithms. And I'm mainly talking about machine learning here, not large language models, can lead to increasing efficiency, just being able to process this history of data. And this is only in the industrial plant. Then we also have efficiencies in the system, as I mentioned in my intervention already, coordinating better the supply of renewable electricity with the demand, forecasting prices and adjusting the production accordingly in the plant, of course, when possible. But there are some opportunities definitely in the system if AI is used in the right way.
Okay, next question is for Tom. Sorry, go ahead. Sure, Dick.
Confirm the figures that Martin gave, because a few years back we installed sort of a digital twin for our aluminum smelter, working with GE. And it was a very, very technologically intensive exercise. It's a very fascinating exercise. Actually, I invite everybody in the audience to look it up. But as Martin said, we live and die by the power costs. So basically, we found out that even though there is some marginal potential for improvement, employing all the AI potential that you can, and even actually installing all these thousands of sensors in different parts of the production to deliver this digital twin and learn from it, and use artificial intelligence to deliver improvements in our business, at least as far as the electrolysis is concerned, we must have ended up with something like closing into the 3% that you mentioned earlier, Martin. So it is an option. It's not a silver bullet, but we're already trying our best.
Next question is exactly on that topic of cost. It's for Tom. The question is from Leah Rom from Clean Air Task Force. Industry needs the business case, but currently economics are not compelling enough. How can Europe reduce the price gap between gas and electricity? How can policymakers support affordable, predictable electricity prices?
Well, I fear I risk repeating myself. I think what we're doing at the moment, what the Commission's doing through the different guidance, the implementation of the existing framework, forthcoming grids package and electrification action plan, is examining every part of the chain of the energy sector and making it work as efficiently as possible, and that each part is giving the right incentives as much as possible. Every study we see that talks about introducing more flexibility into the system shows the billions that come in savings, in system savings from flexibility, which feeds through into lower costs, which feeds through into lower prices. We can look at the way taxation regimes. Member states are already adjusting their taxation regimes and giving exemptions to industries who are exposed to international competition, and more can be done along those lines. So looking at the tariffs, the network tariffs, the way they provide incentives, what they're covering, the way the markets are working, the way the taxes are set, we're looking at every possible instrument there, and we can't do the same as China does or the US in terms of suddenly grabbing cheap, dirty fuel. But we can look at the way our system's working and make every element of it work better, and that will bring significant savings. We've seen some of that already. There's the Ember think tank produced a good study about Spain a couple of weeks ago, showing that in Spain, with the big increase in wind and solar, that's driven gas out from setting the price 75% of the time since 2019. So it's driven gas out of the price-setting role and bringing prices down. So that comes from flexibility and the penetration of renewables. That's our policy, and we want to see more of that around Europe. We're helping member states implement everything to do that, and that's our solution to bringing down prices.
So the last two questions are both for Nick. I'm going to put them to you at the same time. First question is from Guillermo Cardoso from Nuclear Europe. Have you considered nuclear power, namely small nuclear reactors, to power your processes? Yes. Okay. Let me just put the second. Well, go ahead. Yeah. Go.
The immediate answer is yes, we have. Unfortunately, Greece hasn't switched to being a nuclear country yet. So we have been evaluating at company level the options of SMRs as well. The figures are not clear yet. We've been talking to our friends from Newark as well in this regard. So, but also evaluating all the available options, on the table right now. It's a promising technology, but first thing you need to do is, the country has to decide to become one of those, joining the nuclear club. I think some voices are pointing in that direction lately, but it's not something that we're going to see in the near future.
I guess SMRs could be done faster than a regular nuclear plant, but it still takes time. It's still a pretty big political decision. Second question, final question for you, also for you, Nick, is from Alexander Tudoriu from Cogen Europe. Can partial electrification and hybridization with, e.g., cogeneration producing electricity on site, increase industrial flexibility while preserving security of supply and lowering emissions for the industrial sector?
Right.
Mr. Albrecht.
Coming from my friend Alexandra. I said it before, at the risk of repeating myself, I'm going to say the following. Emissions are part of our costs, right? It's not just the sustainability strategy that is driving us, it's also part of our costs. And I think to a large extent, this model that Alexandra alluded to, partial electrification of the industrial heat needed to run our facilities, is basically the core of a proposal we submitted to the Innovation Fund quite recently to cover the incremental need of our alumina refinery after the expansion that we're planning, because we've announced a big project of 300 million euros to mine more bauxite, expand our alumina refinery, and also produce all the gallium that Europe needs. So the incremental heat needed would precisely deliver what Alexandra described, which is a hybrid solution where some of it is covered by electrified processes. That would be for tropical bauxite because it's, let's say, less rough. It needs lower heat. The Greek bauxite is kind of tougher, so you need higher heat rates. So I think that is the way to move forward. Now, for this to move forward, I think Fabien also mentioned it in his recommendations, funding is also needed. Support will also be needed to switch those processes and implement what is commonly referred to as best available practices. Funding for such, integrated projects, unfortunately, in Europe is still not available. So when we submit a proposal, say, to the Innovation Fund, we compete against a standalone CCS project or a standalone green hydrogen project or a standalone sustainable aviation fuel project. Industrial facilities can deliver emissions while growing, emission reductions while growing, so optimal emissions output, but they can't be compared against these projects. So we need a dedicated funding instrument or a dedicated allocation of the existing funding instrument to help these processes, which, again, Tom mentioned that you're going to have an auction at the Innovation Fund for electrifying heat. This is part of an entire project. So we have to look at it in a holistic manner and understand that it's not just the boiler that we're going to add. We're going to add another, alumina refinery, so to speak, right next to it. And both are equally important for Europe because alumina, along with aluminium and gallium, are critical raw materials. So we need help for the whole project, not just for the electric boiler.
Well, I think we've heard a lot of very interesting ideas. Yeah, Jean-Christophe, do you want to close this out?
I just add an additional comment to what Nick mentioned. Hybridization of gas boilers with electricity, an electric boiler, it was put forward as something that's safer, safeguarding the security of supply. I think that was in the question. But I really believe that depends on the grid balance in each country. If you have sufficient electricity, and sorry for my words, but why bother with hybridization? Why not directly jump to electrification? Because if you go for hybridization, then you'll have equipment, control to switch from one system to the other. And that will delay the 100% electrification because you'll need some time before you get rid of your hybridization equipment. So, maybe in some places there's still need because there is not sufficient plentiness of electricity. But okay, my reference is France, where prices are 30 euros per megawatt hour lower than in Germany, and there's plenty of electricity. Just go the fast way and electrify fully. That's
70 compared to Greece, by the way.
Okay.
That is a big difference.
Oh, yeah.
Yeah,
Well, I want to thank all of our panelists, all of us here in the room, and Martin joining us remotely for some really interesting thoughts about how we can get industry working together with the grids in order to move forward on this electrification journey. How about a round of applause for our excellent panelists? And if you've been joining us online, I wish you an excellent rest of your day. If you're here in the room, I invite you now to continue the discussion over sandwiches and drinks just outside these doors. Take care.